Hello and welcome to Clojure Mid-Cities. Tonight I'm super excited to hear about Dawn, an easy on-ramp for Clojure services. And so we'll just go through some of the normal slides that we do at the beginning of each of our meetups. Why does Clojure Mid-Cities exist? This meetup exists to help people explore the functional programming paradigm with Clojure so they can build simpler systems. And so our agenda has been simplified because of COVID. We don't really have a whole lot of news to report right now. So we'll get mostly straight into the presentation, but real quick, I want to once again mention that we've got a meetup discount for the book that Eric Normand is working on. He was a speaker of ours just a few months ago. For his book is Grokking Simplicity. And so the code for that to get 40% off is GRK SMPL 2020. And I believe that I have one code left that will get you a full discount. So I guess if you are watching the meetup, if you message me in the Clojurian Slack, you can find me at John Jelinek, or you could join our meetup channel in the Clojurian Slack, and you can ask me there. So it's first come, first serve. And you know, if you desire it, may you work quickly, right? All right, so our presenter tonight is Mike Nygard, right? So I just wanted to tell you a little bit about Mike. So Michael Nygard strives to raise the bar and ease the pain for developers around the world. He shares his passion and energy for improvement with everyone he meets, sometimes even with their permission. Living with systems in production taught Michael about the importance of operations and writing production-ready software. Highly available, highly scalable commerce systems are his forte. Michael has written and co-authored several books, including 97 Things Every Software Architect Should Know and the bestseller Release It, a book about building software that survives the real world. He is highly sought, and he addresses developers, architects, and technology leaders around the world. And then Michael is also currently Senior Vice President of Enterprise Architecture and Platform Development at Sabre. And so he is helping the company reimagine the business of travel. So I want to just give a quick applause to Mike and bring him right in. Hey.
Hello.
How's it going?
All right. Glad to be here.
Yeah, I'm super excited to hear more about Dawn. So what I'm going to do is I'm going to pass the screen share right over to you, and then I'll let you take it away. And then once again, if anyone has questions in the chat, I'll moderate. If you want to stop during the presentation and ask, I'll give you an update on if there's any questions, or if there's something pressing, I'll stop you. And we'll just go from there. Sound good?
Sounds good.
All right. Yeah.
So I'm talking tonight about Dawn, which is something I started first for my own use and ease, I guess, because we've got a lot of simple in the Clojure world, but sometimes we don't have the easy. So I created Dawn as a way that I could quickly start up a Clojure pedestal vase fern project in a code space. And that's a lot of words that may or may not have a ton of meaning for you beyond Clojure, I hope. So I'm going to start with the last part of it and then work my way forward, because there's a step here that's going to take a little bit of time before we can get to a demo. So let's start with what is a code space. Code spaces are a beta feature of GitHub. It creates a code space is a development environment running in a container hosted by GitHub with code from a repository checked out into it according to the instructions provided by the code space. In that container, you have access to the code. You can make changes. You can run the code. You can run builds. And because the container is built with your credentials, if you have commit access to the project, you can commit and push changes back to it directly. If you don't, you can commit to a fork and then make a pull request back through the GitHub interface. Now, there's a lot going on there. So I'm going to start by moving over to the project page for Dawn. Let's see if I can make that. Yeah, the vulnerability alert goes away. So Dawn here is a relatively ordinary GitHub repo. It's got a README. You can see, like most Clojure projects, it's got a dependencies file, whether you prefer project.clj or deps.eden. This looks totally typical. The interesting bit here is the .dev container. And I'm going to actually start the code space while I explain what goes in the dev container. I have a backup code space just in case. Now, this is initializing that container with my repository. It's going to do some other stuff and things in the background. And then I'm actually going to get an editor here in this tab. So you can see I'm pulling a Docker image so that can get started up. And while that runs, let me talk about what all goes into the code space. So the first thing is that the repo that we were just looking at gets cloned into it. So in this case, the Dawn repo. But the fact that that's my own repo is almost incidental. I can go and look at the repos of anyone else who have configured a code space a file in their repo, and I can start a code space I own with their code cloned into it. Now, this is really nice because there are people doing work out there where the setup on a dev environment can take a lot of time. I've been following the work that Lynn Langet does on machine learning. And if I try to configure my machine with all of the tools and the libraries and the compilers she has, I would spend an hour or 2 hours configuring and debugging the configuration. And that time is time between me and running the code, which means it's time between me and a contribution. So GitHub is rolling this feature out as a way to reduce the amount of setup required and lower the barrier to collaborating and contributing to code. So the source code that gets checked out is from the repo, and it goes under /root/workspace, whatever the repo's name is. In this case, it'll be Dawn. Now, you might be looking at this going, root? Really? I thought we didn't do that anymore. I thought we didn't log in as root. Well, we don't log in as root because you can easily do harm or open security vulnerabilities in a Unix machine that are then hard to detect or close. But if you're in a container, the whole environment is entirely disposable. The only person you could possibly hurt is yourself. And when the container is shut down, anything you've done wrong in that container is erased as well. Now, the other thing that gets checked out or cloned into the container has to do with configuring environments for your personal preferences. And this one's going to turn out to be pretty important. So there's a notion of a .files repo. This is something you can configure on your account on GitHub. And it's your repo that gets cloned in to the same container, and it configures stuff that goes in your .files, right? So in my case, mine is called .files in a display of stunning cleverness, and it has a script in there called install.sh. So as part of creating the code space in this container, GitHub will do the clone, run install.sh, and I should have things like my editor preferences, my shell prompt, and so on set up for me. Now, there's a thing about the .files. and this requires just a little care and explanation. The .files repository must be public. Now this seems like a bit of an odd requirement. So I'll pull up my .files repository here. And indeed, you can see that this is a public repository, and yet it's got my configuration in it. Well, the reason for this, the reason it must be public, is because these files reside next to running code from somebody else. So suppose you had things like your SSH private keys in your .files or API tokens. Well, someone could easily create a repo that looks like a legitimate code space, but when you run it, the first thing it does is snaffle all your .files and ship them off someplace. So it's impossible to prevent exfiltration of data when you're running this code right next to your configuration files. Therefore, GitHub requires you to make your .files repo public as a constant reminder that everything you put in there is public, and so don't put in any access tokens or credentials. Now, the rest of what goes in there is some extra stuff, machinery that gets added to the container to enable networking, including secure tunneling to reach the network of this container, as well as some stuff to support Visual Studio Code. And by now, hopefully, which browser did I have it in? Which browser did I have it in? There it is. So now we have Visual Studio Code running in a browser tab. It's the full editor. I can install all the extensions I normally would. I can browse my files. I can do Git things. And I can even run the integrated terminal. So I have Bash. You can see that I'm in the root of my workspace, and if I like to use Git commands from here, I can. I can also go back a level, and I could clone other repositories here in parallel to the one that's already been cloned automatically. This code space will stay around pretty much as long as I want it to stay around. At the moment, on the beta feature, they're not charging for it, so they do impose a limit of 2 code spaces per person. So I have to choose wisely which ones I want to keep around. But I could customize and personalize this environment and keep using it. When it's been idle for a period of time, the container will be stopped, but it won't be deleted. And so if you go back to try to connect to your code space again, it's still there, but it'll take a little while to reactivate. Now, there is one thing I'm going to have to do in order for the rest of the demo to work, and it's going to require me to stop screen sharing for a moment, because one of the Vase, one of the components of this demo, uses Datomic Pro, and Datomic Pro is not available in public Maven repositories. And so in my .files, I have the basic settings. I have this as a reminder to me to put in my username and password so that I can access the jars. And you can get these by logging into mydatomic.com, and it'll be provided for you. Copy and paste from the screen. I just need to stop sharing for a moment while I edit it in here. If you're curious, I am actually using VI inside the terminal, inside this little window, inside the browser. So it's an effective enough terminal that it actually supports full VI and Emacs. So now let me get back to StreamYard. share my screen again, and we should be good to go. Now, the other thing about this container, you may have noticed I showed the VS Code support and the runtime networking being added to the container after it got started up. And you may be asking, why not simply build that into the container? Well, the answer is that the definition of the container is up to me. I want my container to be a good environment for working on my particular projects. And so part of setting up your project for a code space is creating this dev container folder with a dev container.json description of what the container should be. Now, because that description is under my control, in order to get the extra bits and bobs they need to support it, they have to be injected afterwards. Let me show you what my dev container.json file looks like. And if you're following along on GitHub, you can also just look at this file in the repository. You'll see I have a name for it. The important bit is the image. So this is saying use a container image called mtnygaard/devcontainer.clojure. That happens to be a Docker image, which I have built previously and registered with the Docker hub. So if we go over to hub.docker.io, maybe it's docker.com. Yeah, there we go. So I should be able to search for dev container Clojure, and I'm not logged in right now, so this is public. You can see it. 19 downloads must mean I've started that many code spaces, because I haven't told anyone else about this image. But it's got the stuff in it to preload Java and Clojure for an easy getting started experience. Speaking of easy, it's probably easier to read this if I bump the text size up a bit. So the rest of what I put in here, I have extensions for Visual Studio Code, so stuff for working on Java, and a very popular maturing plugin set for Clojure editing in Visual Studio Code, Calva. And then I have just a few other bits of preferences. You can add quite a bit of configuration to this. So after the image, the rest is describing how to customize the container. Now, I should say, in addition to specifying an image, it's possible to specify a build file here. Now, in that case, it would be something like a Docker file right next to the dev container file. And so in this case, when I start the code space, it would be starting from whatever base image I put in here, and then running the commands to build the Docker file or the Docker container. I've chosen not to do that for this project because I reuse that dev container Clojure image on several different things, so it wouldn't be as efficient for me to have the whole build specified here, but it is certainly possible to do. Okay, at that point, I want to pause before I go into Pedestal, Vase, and Fern and see if there are any questions so far from the audience.
Great, awesome. I do see a question here. So I'll go ahead and read that. Alex Valdez asks, code spaces are in beta. Can we use Dawn with code spaces without access to the beta? And more specifically, he says, can we use Dawn without access to the code spaces beta?
So it turns out that there's a very nice overlap in feature set. If you run Visual Studio Code on your own desktop, it has a feature to run run with your project in a container. It happens to be the same exact location.dev container and the same exact file format and the same exact JSON schema. It's pretty much the same feature. And so if I come over here and I look at my local checkout of Dawn, I could tell this to reopen in a container. And in that case, it's going to do pretty much the same things. And you should be able to use Dawn that way as well. If it doesn't work, submit an issue and I'll fix it, because my intention is that it works for both remote containers running on your own machine, as well as code spaces.
Excellent. Awesome. So that's all the questions that we have right now. So back at it.
Okay, great. Either that means I'm explaining things well, or I've already put people to sleep. So let's plow on and see where it goes from here. There's one other thing I need to do in this editor that has to do with keyboard shortcuts. So Visual Studio Code assumes that it has full control over your keyboard, but the browsers use some of the same keystrokes for their own commands. So for example, if I want to open the command palette in Visual Studio Code, it's normally Control-Shift-P. Oops, I don't need a print dialog. That's not what I was aiming for. So I need to remap that command to a keystroke that the browser doesn't take over. So I can do that through here by saying I want to view the command palette and then say I want to edit the keyboard shortcuts. And well, I've already done it in this space, unfortunately. But let's pretend I hadn't. You would open it directly like this. It would say basically nothing. You'd click Define Key Binding. And I like Alt-X because I'm an old Emacs user. But you can pick anything you like that's not already being consumed by the browser. So I've got that. And then the command ID is Workbench Action Show Commands. And you'll notice that VS Code gives me helpful completions even on the command names inside of here. So at this point, I can now hit Command X, and I get the same command palette that I would normally get with Control-Shift-P. Okay, so now there's probably some way to configure VS Code with dot files, but I haven't figured it out yet, because if you look at the path of this thing, it claims to be /user, but I can't actually find this in the files on my container. It's buried someplace. So now let's talk about, the reason I wanted to bring that up is because I've just shown you two sort of remaining barriers to getting up and running. I mean, you'll notice I started talking about code spaces and containers. I've talked about the settings.xml in order to get my Datomic jars to download, and I've got a key binding. You know, these are arguably barriers to getting up and running and barriers to contribution. And to that, I would say, yep, they definitely are. Code spaces is still a beta feature. There are going to be some sharp edges. We're providing feedback, we being the beta users. We're providing feedback about ways that we're still encountering impediments, and they've been fixing things as they go. At one point, it didn't work at all in Firefox, only Chrome. That got fixed. What may be a bigger issue for some of you is that the code spaces only work with VS Code. So in this browser form here, it's only VS Code. I happen to like VS Code. I'm using it quite a lot these days. Absolutely, your mileage may vary, and you may decide that it's kind of a showstopper and you're just not going to use it. At this point, code spaces is totally coupled to using VS Code in the browser. Okay, so I've got my Clojure project here. It's all checked out. I've got my deps, and so I should be able to actually start Clojure and get an environment running. So let's try that. With Calva, there's a command jack in. borrowed from Cider Jack-in. So this is going to start up a REPL in the project and connect to it. It wants to know what type of a project am I using. So is it, project CLJ? Is it deps.eden? I do have both Shadow CLJS and Clojure CLI configurations here so that I can build front-end and back-end applications. For now, I'm going to pick the simple one, Clojure CLI, and the dev alias, and we'll look at what dev provides in just a moment. So this is starting everything up, and should be just a minute or so. Oh yeah, we have to download a lot of jars. One of the things about trying to make a project easy is that you end up sitting on top of a pretty tall stack of dependencies. And that means you're subject to whatever is going on inside those dependencies. Some of these libraries that are being downloaded are a megabyte of code from which we need one function. That's kind of the trade-off that we make in order to get something that's easy and provides a lot of capabilities out of the box. It does mean we have to stay on top of our dependencies and their versions and vulnerabilities, but that's the price we pay, right? So now I've got my REPL going here. You can see I get a little friendly badge. I just like having that pop out when my REPL starts. You can see this across the room. It's a little nice sort of sign of recognition. But now I've got my REPL. I can do all the things that I would normally do. Oh, that's interesting. Probably need a space there. You'll notice little bits popping up as I type. This is coming from one of the pieces that the dev alias brings in for me, which is a readline library called Rebel Readline that provides hints and completions as you're typing things in. So this is a great way to get into a project because the project itself starts to tell you what's available. So in this case, I'm going to require dawn.main, and I've obviously forgotten my script. Oh no, I forgot to commit something from another instance of this project. Apologies while I fix that. I'm just going to see if I have it someplace else. Did I have it there? No. Well, you may get to see some more live coding than I actually anticipated. I know I have it in the other code space that I set up as a backup, just in case something went wrong here. But I don't want to spend the time to go activate that. So bear with me just one moment while I try to remember someplace that I can crib this from. Here we go. Now, this probably looked like kind of a lot of effort to try and get just a few lines of code, but they're worth it. They're good lines of code. So we're going to start with a main.clj. And there's not a lot here. That's kind of the point. We're trying to make this super easy or I'm trying to make this super easy on myself by bundling all these pieces together. So what do I have here? This vase.fern namespace is part of a vase, part of the library called vase that uses fern to start up a server from a data file that describes what the server should do. So let me pause for a second and give you a schematic for how this all works. some people were calling this the Cognitect stack. Actually, even within Cognitect, this is kind of a subset of Cognitect that used this. Pedestal is a web framework that's it's got some nice features. One of the things that it got kind of baked in is this idea of interceptors rather than functions and middleware. So if you've been exposed to Ring, you've seen the idea that that ultimately an HTTP request is asking for the execution of a function, and that anything you want to put around it is a function that wraps another function, and then a function that wraps that, then a function that wraps that. And when you finally make your call, it threads through the front half of all of this middleware, you know, function of map, calling another function of map, calling another function of map, actually does your function, and then on the return on the way out, everybody gets another chance to modify the map. In Pedestal, what we said was, that's great if all of your execution happens immediately and all at once, but it doesn't work as well when you're dealing with things like WebSockets or server-sent events, where you can have asynchronous communication going on for some time. That whole middleware model of functions wrapping functions doesn't work when you don't have a single call stack. And so what we have these things called interceptors. And let me see if the docs I wrote are still there. Yep. Come on, okay. So the idea with the interceptors are that we're going to pass the map through a chain of interceptors. It sounds exactly like the functions I just described, except the difference is that the interceptors are data. They are not closures around functions. And so you can change the execution that's going to happen dynamically as you're doing the execution. You put more things into the interceptor chain, or you remove the interceptor chain. And crucially, because it's data and not the call stack, you can actually make an asynchronous return. And we hold the interceptors around and let you continue to emit events, for example, after the functions have returned. Now, this is a lot of inside baseball around web frameworks. And building the interceptors wasn't always very obvious to people when they were getting into it. And so in looking for ways to make this easier, we looked at some of our most common use cases and said, a lot of what we're doing is building services to put an HTTP API on one end and a database on the other end. And you know, that's basically the same task that only varies in terms of the API routes and definitions and the actions you're taking on the database. There's sometimes not any logic in there other than shuffling the data back and forth. When there is logic, we can usually express that logic in fairly discrete pieces that don't need to be complected together with HTTP handling and JSON parsing and all of these other things. And so a guy named Paul DeGrandis created the first version of Vase, which said, let's, you know, now that we've turned our web framework into stacks of data, let's also create those APIs from data. And so Vase is a project Vase is a project that Paul created and I contributed to that allows us to create what we call data-driven microservices. So you create a small definition file that says, what is the API that I want? And I have a better example than on that site. You just describe the API in terms of the data about its configuration. And then when you start up your service, Vase will generate Clojure code for those pedestal interceptors, and it all gets compiled down to bytecode. And so we get the benefits of the very high level specification of the API and the performance of running, bytecode as if you had hand rolled your Java application. Now, the limitation of Vase in the early days, was a prototyping tool. I'll say the data model that we were asking users to write pretty much reflected the mental model or the internal structure that the Vase developers had in mind. And so we went through a couple of iterations trying to find a better way to write this. And so Russ Olson and I created something called Fern, which is a friendly language for data. And so the image is we have a pedestal, on the pedestal sits a vase, and inside the vase is a fern. Why a fern, not a flower? Ferns are simpler than flowers. Flowers are ornate. Genetically and biologically, ferns predated flowers by a very long time. So all of that is to say, that's what's going on in this one line here. We are asking Vase to create a server from the fern definition that we're going to pass in the file name. And it will create that server and start it up running on whatever port you tell it to, and then return the server. So let's give this a try. You know what? I'm going to not use that window, and I'm going to use the Calva window because it's just nicer. Okay, that's done. And so now I want to make sure that I grab the value that gets returned here. And I need to tell it what fern file to use. Some of you know what's going to happen next. Nope, that's not what I was expecting. Calva really didn't like that. Let me try that again. No such var? Did I not save my file, perhaps?
I'm not sure that you've eval'd the file yet.
Well, it should have happened here, but let me do it through Calva to illustrate that. So Calva will also let me say load the current file. It's taken a little while, but it's loading that whole stack of dependencies. There we go. Okay, so so now it's in there. Thank you, John. And at this point, oh, okay. We get an error message that says no such file or directory. This is, I think, a much nicer error message than one normally gets from Clojure. And we actually put a lot of work, Russ and I, into handling errors from reading this file well and reporting them well, so that you had a lot of information about what went wrong and where the problem really started from. And this is one of the benefits of Fern over, say, raw Eden readers. When you use the Eden readers, the stack trace tells you pretty much nothing about what's wrong with your file. It only tells you what went wrong in the code inside of the Eden reader itself, which is not generally going to lead you to where your syntax error is. But we don't have a syntax error yet. We just don't have a file. So let's make that file. We need a directory resources, and we need a file. And so from here, that is the simplest file we could possibly have.
So I think you put the file in your .resources, or sorry, .calva directory.
Thank you.
Yes.
Yes, it would not be found there either. So this is pretty much the simplest Fern file you could have, but it's not terribly interesting. Where it gets more interesting is when we say we want a service. Now, the structure of Fern is it's a map. On the left side of the map, you have symbols. On the right side of the map, you have values which can include certain expressions. And in this case, the expression that I'm going to use is something called a Fern literal, which is sort of like saying, don't evaluate this when you read the file in initially. Wait until you are asked, and then use this key in a multi-method to produce the value from the remaining content. And so it's a little bit like macros, right? With a macro, you're saying, don't evaluate everything yet, pass it through some other piece of code, and then use the value that that returns. So it's a way of deferring evaluation, also in a way that Eden does not allow. And so what goes inside of the literal is kind of up to the definition of the literal. So in this case, base service expects certain things to be present. In particular, it wants to know what APIs you're interested in. So I'm going to use a sample one. And it needs to know what configuration to use in starting up the HTTP server, the Jetty server. Now, I've used this at symbol. At normally means take the value of a reference. So find out what's inside an atom or a promise or a ref. In this case, what it means is go find the symbol API v1 and use its value here. And so instead of trying to nest everything inside, and end up with maps of vectors of maps of maps of vectors with lists of maps and so on, we wanted to keep everything really flat because it's easier to read and comprehend. And actually, you end up getting a nice sort of columnar alignment. So your eye easily bounces from down the left-hand side and finds the symbols you're looking for. And so here I can say my HTTP options are like this. These are all pretty much straight from Pedestal and its documentation. So if you were to go look at that, these are the things you would be asked to pass in. I'll explain these in just a moment. Okay. So what do we have going on here? Well, the resource path says I do in fact want to serve static files. So I'm going to allow things to come from public. Port is what port am I going to be listening on with my HTTP server. Join is a parameter that says whether after creating the server, we're going to wait for the main thread to terminate before we return. So if you do that, what you're saying is, go start this server and don't return to me until the server exits. That's not all that helpful in a REPL. We'd really like our functions to return. And so when you're in a dev mode or a test environment where you want a REPL available, setting join to false means return me the server right away, so I still have it as a value and I can poke at it. The secure headers is some unfortunate boilerplate. We need to keep Jetty happy and avoid nasty messages. Okay, so that's HTTP options. Now, this name is totally up to me. I can call it whatever I like. There is no significance to it. There are only two magic names that have any meaning to Vase, and that is Vase/service. So it's definitely going to look for that. And it's also going to look for Vase plugins, which it expects to be a list of namespaces to load before evaluating anything else. So if you want to extend the Fern literals with your own extra stuff, that's how you do it. You put it into a namespace. It's just a def a def method on Fern/lit, and that's how you add your own literals. Well, we've used this in other places. So we can start to say, we have an API. And that API is going to be another literal for Vase API. And now we get to say, where do we want it exposed? So it's going to be mapped under /v1 from our web server. We have some options for vectors of interceptors. On startup is a vector of interceptors that will be executed when we start the service, and on request is executed on every request. And then we have our routes. Now, in previous iterations of frameworks, you might expect to see the routes nested under here, and then with actions for routes nested under there, it gets really unreadable. So again, we're going to use this and say, let's use a little bit of indirection and give ourselves the ability to put the routes flatter at the top level. For our purposes right now, we're going to do the simplest route, which would be just a kind of a hello world. So we have a set of routes. This one goes under hello, responds to the get verb, and when prodded at the get verb, it invokes a literal called Vase respond. Now Vase respond is one of the pieces built into Vase, and I get to put in the body of the response like so. What we've done here is specified some code that will be passed through this lit. The Vase respond literal generates more code and compiles it into an interceptor, which it then returns. And so what we really have, you can think of this whole thing as being, the function to invoke, or the interceptor with its enter and leave functions. That route is part of the set of routes that I'm calling API v1 routes, that I'm linking into this API, and that I'm saying is one of the APIs that I want Vase to expose. So, seems like a lot of stuff. I said this was going to be easy, and this doesn't necessarily seem easy yet, but we'll get there. Let's stick with it a little bit longer. So let's try this again, where we're going to start a server. Oh, interesting. We got an error. We can't create the service map. What went wrong? If you can't tell, I kind of rehearsed this. As I look back up here to the beginning, I see a message that tells me my spec failed. So here is the expanded value. So I see my API is key. On startup, I've got a problem with it. But before we go into the problem, let's look at some of the other stuff, because this expanded form shows us what we got. Here's our route. And this is what resulted from the Fern lit on Vase respond. we got, interceptor from line 19. It takes no params. It does no coercion. It's got a body that says, hi there. We're not supplying any special HTTP status, so we get a default of 200. We're not supplying any headers, so we respond with the security headers. So this is kind of showing us how the Fern machinery for producing values that Vase consumes works. Okay, and here's our spec failure. My empty vector should satisfy this spec. I don't know how many of you have looked into Clojure's spec.alpha yet, but this spec is a predicate that gets run on the value. And if this expression returns true, then the spec passes. If the expression does not return true, then it does not. And so this says it should either satisfy this, that there is somewhere between 1 and integer max value items in the vector, or the vector is nil, but it didn't satisfy either of those. Oh, and it turns out we have a second spec failure on the onRequest key. And not surprisingly, that is also constrained to say, don't give me an empty vector, either give me at least one interceptor or give me a nil. So for the moment, I'm just going to comment these out. We don't actually need them to be an empty vector. So let's see, third time's the charm, right? Let's try and get our server. And we're waiting for Jetty to initialize. And we're waiting for Jetty to initialize. Obviously, running in a code space, it's a container on somebody else's hardware, so they don't always necessarily devote as much CPU to it as you might like. This is starting to take an unusually long time, though. And that's from the previous execution. This may be the part where I show you how to stop the REPL and start a new one. Yeah, I'm just not getting any response there. While we're waiting for that, have any new questions come in, John?
All right. No new questions at the moment. I see that at least one person saw the need to add the S to your routes from earlier.
Okay,
where
good.
You're defining that, but
Good.
But you caught it, so I was gonna wait and see if you caught it. So.
Oh, all right. Testing.
You did good.
Okay. Okay. Good. To figure out which keystroke actually submits, because one thing that's a little funny, and I haven't tracked down whether this is a code spaces thing or the version of VS Studio or VS Code, but I don't know why I'm getting the extra new lines over here.
Yeah, that is interesting. I think I've been doing Control Enter when I've been using Calva.
Yeah, I have too. And it's just taking a long time.
Maybe you can run top in your terminal, right? We can see.
Oh, there it goes.
Here you go.
All right, finally. Okay, so let's try this again. problem is I hit Control Enter and it doesn't give me any visual feedback that it's submitted anything.
Yeah, that is a bit unnerving.
I wonder if I got a loop here somewhere. We actually did write code to check for infinite loops in or circular references among keys and values. But I just don't understand why it's taken so long.
Well, if you want, we can take a question.
Please.
Sure. All right. So Daniel Craig asks, is the Cognitect stack a commonly recognized name?
No, definitely not. That's why I put it in irony quotes.
Right.
Okay. Oh, did you just do something? No, it did not do something.
Yeah. Do you maybe want to try this part just down in the bottom REPL instead of through Calva?
Well, the problem is that I may get a port conflict.
Okay. Oh, I meant if you stopped the REPL and restarted it. But yeah, you could pick a different port too.
It is. Address already in use on 8080. I doubt that. Let's try 8081. So here you notice that I have to choose between getting nice command history and getting nice color coding and highlighting and all of that. Well, something very strange is going on. Where is this file? Resources, server.fern. You know, instead of trying to sit here and painfully debug the demo, I think what I would like to do is show the next step, which is where you start to get some value from the machinery that's already been in place. So that looks like this, where I'm going to grab one of the later examples from inside Vase. So this is one of the Vase samples, our good old pet store. And what I'm going to do is grab, well, I might as well grab everything. No, I might as well just talk through it here since we're not getting a demo working. So this file adds some pretty big magic. So I already mentioned the Vase/service key. We've seen that. Now I'm defining some new ones. So Datomic URI. Datomic is a database. It's created by Cognitect, so I probably could have put that on the Cognitect stack. In this case, we're using an in-memory store because we're in kind of a dev mode. But you can certainly use this definition. And now you could also use Datomic Cloud to connect out to a cloud instance. The HTTP options are just the same. But now we've got this new one called connection, where the lit is vase.datomic/connection. This actually just comes from another namespace that defines additional methods on the multi-method fern lit. And so you can extend it not just for Datomic, but you could extend Vase for any kind of data store or API that you wanted to call by adding new lits. Now in this case, we're saying Datomic connection with an @Datomic URI, which says I'm going to fill this value in here, and that's how I'm going to connect. connection is referred to in the onStartup for the pet store API. So this says on startup, I want to connect to Datomic. The next thing that happens on startup is this one that says pet store V1 Schema, which is right here. And this literal is for attributes. This is defining my Datomic schema in line in my server definition. So this defines an attribute called pet ID. It's a single valued attribute, long type, and it is a unique identifier. And we've got a little doc string with it. Likewise, we've got a name and a tag, which are both single strings. By having this in the onStartup, we're effectively applying migrations. Every time we start up the service, we are ensuring that the Datomic schema is what we expect it to be. Now we have another onStartup here that I would use in a dev or a test environment, but would not use beyond that. And that one executes a Datomic transaction. And so in this case, these maps are Datomic transaction data, exactly as you could pull it off of the Datomic documentation site. Each of these gets executed. This is a transaction with 5 maps. So it creates 5 entities, all in that one seed transaction. So by the time the API is even started up, we've got our schema, we've got our connection, we've got our schema, and we've got some seed data in there. When a request arrives, we're going to use this value for the routes. But before that happens, we're going to, again, invoke the connection. Now, this one's a little bit tricky. I'm not 100% proud of it. It's kind of clever, but maybe not wise. And so it's something where I've wanted feedback on it. The connection value can play 2 roles. At startup time, it actually makes the connection out to Datomic. At request time, it attaches the current connection to your request map. And so you can think of that like in a traditional SQL database, you might have a connection pool, and when a request comes in, you check out a connection from the pool, you attach it to your request context and pass it through. This is kind of doing the same thing, except Datomic does its pooling internally, so you just need to attach the connection. The next 2 parts are referring to interceptors that are provided by Vase, and it says I want to use body parameters, so decode them, and I'm using JSON bodies. So by putting these on there, it means I'm using a JSON API. Again, I've defined a route mapping, so this is prepended to all of the routes in the route table. And what do the routes in the route table look like? This is where I think the power of Vase and Fern really start to show. So let's look at this one, which is /pets and a get verb. So this is our collection resource, and we want to list out the pets. This is not a very scalable approach, by the way. You don't normally list out all the pets, but we wanted to keep the sample simple. So again, we've got the @ so we're going to follow this symbol to pet store V1 find pets, which is here. And this is a Datomic query interceptor. So in this case, because we're finding all pets, we don't use any parameters from the request. This is the Datomic query, and the results get marshaled as JSON and sent back directly. And so the entirety of the logic for handling that route is here. That's it. That's the whole thing. Likewise, suppose we want a specific resource URL. We have a route that can match with a parameter. So we've got a path parameter. And it's a get verb. Our interceptor is find a pet. Here it is. It is a query. It says that we need to coerce the ID as Eden. Effectively, what this means is if it's a string and it looks like it should be an int, turn it into an int. So this goes through the Eden read string routine, or the value of the ID parameter goes through the Eden read string. But before that can even happen, you have to say, yes, I do actually want to look at the ID parameter. Make sure that that's available. This is a measure of safety because sometimes running bits of strings from URLs provided by clients through your parser, not always the safest thing to do, so you have to be explicit about it. But then once we have that ID value is available in this query. And so here we're doing a query where we say, previously we were looking for any pet ID. Here we are constraining the pet ID to match the parameter being passed into the query. And so this is our database logic. Fern lets us express this in a nice flat syntax with the connections being made. Vase turns it into high performance runtime bytecode. And Pedestal runs it all on Jetty with a very flexible execution model. You can see that we have other ways of doing transactions. So if you want to add a pet, we've got an operation, we've got a transact with an operation for asserting an entity. That's actually the default, so you could leave that off. We've got a transact with an operation of retracting an entity. And so, here we're putting the whole pet in, here we're deleting the whole pet, all by ID. So this is our CRUD interface for pets, along with our entire server configuration and our schema migrations in 74 lines of data definition with comments and white space. So this is where the easy part starts to come through, because I can take this and, given an API specification and a data model, I can create CRUD services in a few minutes. I can create services with logic in something like an afternoon. What I haven't shown you around the logic is that this doesn't have to be just one thing. We can also make it a vector and put in our own validations. So we could say pet store V1, I don't know, no cats allowed, right? And then here we're adding a new interceptor. Maybe it's an interceptor that we're creating in code. So I've got a whole namespace that's like the dog store. So here I can say I want my dog store, no cats allowed. And that's probably going to be a Fern lit because it's likely I want to parameterize it with, even the fluffy ones. Something like that. Now, for that to work, we need to go back to our extension API up here, or our extension key, and say base plugins, dog store. But now what we get is the ability to use this easy mode stuff, all in Fern, along with selective extensions where we're breaking out of the Fern work to go do harder things. And so it's not the sort of all or nothing approach that you sometimes see with data-driven web frameworks. We allow you to incrementally replace the easy bits with more sophistication where needed. So with that, my code samples are at a close, my demo's at a close, my code space will soon be at a close, and it's definitely time to take some questions.
All right. So I see one question here from J.R. Smith. It says, can you attach specs to incoming requests and or payloads via Fern?
Yes, a combination of Fern and Vase. So there is a Fern lit provided by Vase, which attempts to conform an incoming value to a spec. If it's the only interceptor in the route, then an error is immediately reported back to the caller. So you get something like a bad request response with the spec data about why it failed. If you have a chain of interceptors, then instead of automatically generating the response, the spec failure is attached to your request map, so it's available for inspection by downstream interceptors. We do that in quite a few places in Vase. So for example, when I showed you the query, if the query is the last interceptor, then whatever the query returns becomes the response. If it's not the last interceptor, the query results are available on a key in the context map that your downstream interceptor can look at and use.
Awesome. Okay, so there were no other questions from the chat, but I have a question for you.
Mm-hmm.
Is this framework or collection of composed libraries something that you would take to a hackathon, or is this something better for an enterprise type of project where I've got some sophistication and I need to be worried about tech debt down the line? What's your thought there?
I would be comfortable taking it to either one. I think it's easy enough and fast enough for a hackathon. I have sat down with business users and talked about the data and started showing it to them. And if you use something like Postman as your client side, it gives you a good enough visualization that like business users will be pointing at your screen and saying, no, it should be more like this. And then you go back and you edit your Fern, and 10 seconds later, you've got the new API. So, that kind of collaborative, iterative work is fantastic. As far as using it for an enterprise, I have used it at enterprises and would do so again.
Excellent. Awesome. So while you're answering that, a new question did come in. So Daniel Craig asks, is Datomic overkill if I don't need to do anything that really plays to its strengths? I want to try it, but I don't think that I need it.
That's a great question. And it kind of depends on which Datomic you're talking about. So right there, I was using Datomic Pro with the in-memory storage, if you will. I use that in-memory for quite a lot of things, including one of my larger personal projects around knowledge management. And that's because it turns out there are a lot of cases where you might be tempted to build a graph of objects and then traverse through it in various ways. But if you look at it a little harder, you realize I'm actually just building a specialized in-memory database inside my application. So I think there's a great role for embedded databases in applications. Now, Datomic can also scale up quite big, and there is a step function that you incur when you need to go paid. Let me be careful. I don't work for Cognitect anymore. I did. So Datomic, you can take Datomic all the way to production without talking to Cognitect or paying them anything. It's not open source, but there is a $0 option that lets you go all the way into production. But your question was not as much about the cost as it was kind of the cognitive overhead, I guess. And I'll say the stack I've shown you works very, very well with Datomic. But I have also written Fern literals that did the same kind of thing on a Postgres database. It's just a matter of writing a namespace that supplies those literals and can be invoked as an interceptor from time to time.
Excellent. So on that topic, have you open sourced the interceptors for Postgres, or is that available?
Sadly, those were written for pay at a client,
Okay.
so have not. But I can tell you that they only took a couple of days to write.
All right. Yeah, sounds like a community project.
If there's some time when we're allowed to sit down around pizzas, I would love to work on that with somebody.
Yeah, absolutely. Yeah, I may hit you up on that. I think I might be interested in that use case. There is another question from J.R. Smith. It says, are there any good interceptors for handling auth?
Oh man, that one is a tough subject. The best set out there was called Buddy. I'll be honest, I haven't looked at Buddy in a little while, and it may have dropped support for Pedestal, or it may have fallen into disrepair. But that's probably where I would go first. And I might find a message on the project that says this project is obsolete. Go look at this other project, and I, just keep following the links. There's a distinction that we need to make between authentication and authorization. So the interceptors for handling authorization are pretty easy to write on your own. I mean, effectively, you're creating an interceptor that will look at something about the request context, and depending on the results of that decision, will push an interceptor on the stack that actually goes to the real route, or it will respond with a go pound sand HTTP code. With authentication, most of the time we're not really interested in running our own login forms anymore. With authentication, you're probably more interested in something like OAuth or OpenID Connect. And sadly, I just never had a project where I would have been able to add the OpenID Connect support into Pedestal. But it would be a very valuable addition. So, JR, that's all kind of a long-winded way of saying, no, there aren't good ones, but there are some that you could cobble.
Awesome. Yeah, thanks for sharing that. So I think that's all the questions that we have for now. So once again, I want to thank you for teaching us about Dawn, and I hope to play with it pretty soon myself.
All right.
Yeah.
Well, thanks. Glad to be here.
Yeah.
Hope everyone
Awesome.
had a good time. And
yeah.
Looking forward to when I can see you in person again.
Yes, absolutely. Yeah. I mean, I can't wait to start meeting a lot of people in person again. All right. Well, thanks a lot. And so I'm just gonna pop back over to my slides, right? And so, here's pretty much the end. So thanks everyone for coming. We'll see you next month, hopefully, unless there's anything crazy that happens, which, I mean, it is 2020, right? So anyway, as always, if you need to reach out to me, you can find me in the Clojurian Slack. And then also, if you want to propose a topic, or if you're interested in speaking, please reach out to me, and we'll get you on the roster, right? So anyway, thanks a lot for coming, and we will see you when we see you next. Thanks.